Hi YouTube, Brittany speaking, broadcasting from the Ray Biotech US headquarters. I'm here to simplify common biostatistical methods and techniques. In the biology field, we often ask, how does this sample group compare to another sample group? Biostatisticians and bioinformaticists can help answer this question by applying complex algorithms and concepts. Diligent scientists love the insights in math and the data control that comes with coding, but most of us simply want to understand the basic principles behind continually cited analysis and then get the coders to run it for us. This Biostat series untangles a suite of popular techniques one by one, including those that use machine learning as a calculation approach. The full write-out can be found on our website in our resource library, along with a plethora of other informational guides. This series is a broad-scale understanding of common biostatistical methods. No math, coding, or advanced degree required. First on the list is a notable machine learning technique. Hierarchical clustering characterizes how similar or dissimilar samples are based on overall patterns of measurement. For example, the groups may be patients and the overall patterns may be derived from protein expression across numerous proteins. Hierarchical clustering analyzes the similarity in a binary fashion, starting from one sample. Okay, so when is it used? The test is performed to stratify samples, meaning you cannot dictate how many clusters are made. Some corresponding questions are, how similar are cell lines X, Y, and Z based on their expression profile? How many subsets of breast cancer are there based on expression profile? Is the expression profile of a treated patient more similar to a healthy patient or a diseased patient? Great, we've established logical questions to ask. Our next question is, how does it really work? Hierarchical clustering uses a machine learning algorithm to create a cluster dendrogram, which depicts how groups cluster together. We created this figure with these steps. First, the protein expression for each protein across 8 patients is centered and then scaled by taking into account the mean and standard deviation, respectively, of the expression values. Expression level of protein X across 2 data sets is centered, so the mean is 0, and then scaled, so the standard deviation is 1. This step standardizes the data set. Second, the Euclidean distance, or the closest distance between 2 data points based on value intensity, is calculated. Third, 2 closest data points are clustered together, which are not treated as one data point. The next 2 closest data points are clustered together, and so on. This continues until all the data groups are merged into one cluster. At the end, data looks like this. Hierarchical clustering produces a heat map with cluster dendrogram and a table outlining which clusters work together. All right, so here's a keyword for you. Hierarchical clustering is an unsupervised machine learning clustering strategy. Next up is K-clustering, another machine learning technique with a differentiable clustering strategy.